It is my honor to invite our friend Parasar Patel to deliver us the lecture on corrosion, and the title of the presentation is A Demonstration of Iron Corrosion. This is to induce critical thinking in students. Parasar, thank you for agreeing to lecture. Please go ahead.
So good morning everyone. My topic for the presentation is a demonstration of iron corrosion to induce students critical thinking. Abstract. Evidence-based reasoning and critical thinking are two crucial scientific abilities of students, sharing a close relationship with each other. However, in real teaching circumstances of experiment classes, students easily directly accept the conclusions they have been given without critical thinking and full comprehension of the relationship between experimental evidence and the resulting conclusions. During implementation, instead of showing the well-designed experiment scheme directly, the teacher first showed the preliminary outline and then reviewed the process of revising the outline gradually. In each step, students were asked to see evidence and flaws as the basis for the subsequent revisions. The performance of the students during the class showed that the students' attitude towards the demonstration experiment has changed from passive acceptance to active reflection and questioning. Introduction. Evidence-based reasoning refers to the process of drawing a scientific conclusion out of a real case based on observing the factual situation, extracting the relevant evidence of material reactions, and using analytical methods to deduce the final conclusion. Critical thinking as a high-level cognitive ability should be derived from the education and training, making it a kind of mental habit and a psychological strength. It should be emphasized that critical thinking is not to refute whatever you want to, but a logical and unbiased reasoning based on evidence. Therefore, critical thinking and evidence reasoning are closely related. A survey by Bank showed that high school students lack active thinking, questioning spirit and awareness of evidence and reasoning process, and have overall low critical thinking ability. Electrochemical corrosion of iron is a case closely related to our daily life. According to different conditions, the electrochemical corrosion of iron can be divided into hydrogen evolution corrosion and oxygen absorption corrosion. The Chinese high school chemistry textbook describes that hydrogen is continuously released during a corrosion under acidic conditions, so this process is called hydrogen evolution corrosion. But if the water film absorbed on the iron surface contains dissolved oxygen, the so-called oxygen absorbing corrosion will occur in a neutral or weakly acidic environment. The reaction equations of hydrogen evolution corrosion and oxygen absorbing corrosion of iron in an acidic environment are as follows.
Beautiful. Can you please show this slide? Dear students, you see Parasar is presenting like an experienced teacher. Do you see a graduate student in Parasar? I see an experienced chemist and teacher in Parasar. Parasar has told us that corrosion, especially in the specific example of iron, can be two types: hydrogen evolution or oxygen absorption. What a beauty! The pH, effect of pH on corrosion. He is telling that the acidic environment is the culprit here. Can you please read out the same slide once again for us? Please see the equations. 1 second, Parasar. Please see the equations. The first equation is called iron solid, means metallic iron getting oxidized to iron 2 plus. When 2 electrons are given out, it is called oxidation. Oxidation reaction is the one wherein electrons are given out. Reduction is a reaction wherein electrons are taken up. Okay. Reduction, oxidation. Oxidation reaction happens at anode, electrode. Okay. Reduction reaction takes place at the electrode called cathode. Okay. Then here 2 hydrogen plus protons plus 2 electrons giving rise to hydrogen gas. Usually we represent gas by an upward arrow. Downward arrow means something called a precipitation. That is different. You should be very, very careful with these arrow marks. Solid is represented differently, gas is represented differently, okay, liquid is represented differently, okay. Equilibrium has a specific symbol, okay. Forward reaction and backward reactions have a specific symbol. We have to follow the convention. Chemists are very particular about convention, okay, notation. Please, Parasar, go ahead. Read once again for us the same slide. This is what is called getting by heart. This is what is called exam preparation. If I ask you the question, what is corrosion of iron? I expect this to be written. Agreed? This is the material. What additional material you need? I pity. Please go ahead.
The Chinese high school chemistry textbook describes that hydrogen is continuously released during corrosion under acidic conditions. So this process is called hydrogen evolution corrosion. But if the water film absorbed on the iron surface contains dissolved oxygen, the so-called oxygen absorbing corrosion will occur in a neutral or weakly acidic environment. The reaction equations of the hydrogen evolution corrosion and oxygen absorbing corrosion of iron in an acidic environment are as follows.
Beautiful. Thank you for introducing to us the specific example of iron and its corrosion in acidic environments. Please go ahead, Parasar.
So as sir explained the first two reactions, for the third reaction, Fe solid reacts with 2H plus, which is in aqueous state. It gives 2 Fe2 plus, which gets here Fe gets oxidized in aqueous state, plus hydrogen gas is also released. Then 2 Fe solid again gets oxidized to 2 Fe2 plus aqueous plus 4 electrons are given. Then these 4 electrons are used in the next reaction when 2H2O molecule, which is in liquid state, plus O2 gas plus 4 electron minus gives 4OH minus aqueous state. Then 2 Fe solid plus O2 gas plus 2H2O in liquid state gives 2 FeOH2, which is the end product, which is the cause and which is also known as the rust or end product of corrosion.
This is ferrous is Fe2, ferrous, ferric. How to distinguish? Us-ic. You should be very careful with this. Okay, us-ic. Lower oxidation state is always us. Cuprous, cupric. Okay. What is cuprous and cupric? What is ferrous and ferric? Ferrous. Ferrous 2 plus, ferric 3 plus, cuprous. What is cuprous sulfate and cupric sulfate? Okay. Parasar, can you write to us on cuprous and cupric on the board? Cuprous and cupric. Cu2 plus. Cu2SO4. Cuprous sulfate and cupric sulfate. Can you write? Yeah. Our friend Harshit has clarified it very clearly. Cuprous, Cu2SO4, cupric, CuSO4. Am I correct? Good. Cu plus is called cuprous, Cu2 plus is called cupric. Agreed? Agreed? Us-ic. There is a confusion, electrochemistry is always confusing. The redox potentials, the table is confusing. You should be very careful with, electrochemistry. Yeah, you see how Parasar is writing like an experienced teacher. There is much from you to learn. Okay. Yash Gohil has presented a wonderful lecture, the scientific race during the times of, the discovery of nuclear fission. Please go ahead, Parasar. Yeah. Us and ic. Here, ferrous is 2 plus, ferric is 3 plus, ferrous hydroxide. That is what the corrosion product. Okay. FeOH twice. Yes.
However, Lee and Tang reported that hydrogen evolution corrosion happens under acidic conditions and oxygen absorbing corrosion occurs under neutral or alkaline conditions. is a misleading statement widely existing in Chinese chemical education. In other words, it is easy for students to have the misunderstanding that iron does not undergo oxygen absorbing corrosion in weakly acidic environment but only in a neutral or alkaline environment. In order to avoid such misunderstanding in education, there have been many experiments trying to prove that the iron will also undergo oxygen absorption corrosion under weakly acidic conditions. The most used idea is to put iron and carbon powder in a closed system under weakly acidic conditions and monitor the changes in oxygen content. Any system gas pressure and system gas pressure.
Good.
Such experiments use a decrease in oxygen content and decrease in pressure as evidence to claim that oxygen absorption corrosion occurs in the system.
See, beautiful experiment. Such experiments need to be devised and included in the curriculum. That is the idea with which I am presenting these topics. Of course, not me. You are presenting the topics. I want in our curriculum ethanol production. I want in our curriculum biodiesel transesterification reaction. I want in our curriculum laboratory at least. Ion corrosion. Here, in a closed system, the oxygen pressure is monitored and it is used as a measure for the corrosion of iron in acidic conditions. Yeah, such a clear presentation I have not expected from you. What I expected from you is, truly speaking, read the abstract and read the conclusion. 5 minutes, ho gaya presentation. But you did beyond my understanding, beyond my expectation. I appreciate. I have never seen any BSc student presenting such a beautiful lecture. Yeah, please go ahead.
Some researchers have tried to improve the above mentioned experiment by adding a step of monitoring the system's pH value. Increase of the solution pH was used as the evidence to make the deduction that OH minus produced by the positive electrode leads to the pH change of solution and claim that existence of oxygen absorption corrosion.
Yeah, what is positive electrode? What is positive electrode and what is negative electrode? Cathode, anode. Cathode is positive, anode is negative. Am I correct?
No, sir.
Opposite. What is the positive electrode?
Anode.
At anode, what happens?
Oxidation.
Anode, oxidation. Cathode reduction. Okay, yeah, please go ahead. Yeah, please go ahead.
However, the closed system used in the experiment is different from the actual situation of ion corrosion, open system, which may also introduce additional bias. Therefore, the experimental evidence reasoning is still not rigorous enough. The demonstration. In the demonstration experiment, an iron platinum primary cell was used to simulate the iron carbon primary cell formed naturally in real situations. A different pH value was created by titration. A hypoxic environment was created by injection of helium gas. Microcomputer-based laboratories, including pH sensors, voltage sensors, and dissolved oxygen sensors, were used to measure the parameter changes of the system under different conditions. The demonstration experiments were divided into 6 steps. First being measuring of pH, then measuring of voltage change, then repeat pH and voltage measurement, then fourth step being measuring voltage change, fifth measuring dissolved oxygen concentration change, and sixth measuring dissolved oxygen concentration change in hypoxic condition. So step 1, measuring pH change. The computer data collector, drop count sensor and pH sensor were connected. A mixed alkali solution was titrated from the plastic titration tube into a beaker containing 50 grams of mixed acid solution. In the whole process of titration, the drop count sensor was used to measure the volume of the added mixture alkali solution, and the pH sensor was used to measure the pH of the solution in beaker. As you can see here in the picture.
Here, what is the mixed alkali we are talking of? Mixed.
To create the weakly acidic medium for the experiment, they created a mixture.
Mixed alkali means?
Sir, alkali mixed with this other solution. like acid was added, alkali solution titrated, 50 gram of acid solution. With it they added alkali to like bring the pH to the like specific point where they wanted to conduct the experiment.
Very good, very good. Okay, please go ahead.
So as you can see here in the picture, this one is the pH sensor, the drop count sensor, the horizontal one, and the titration tube. For step 2, measuring voltage change, the computer data collector, drop count sensor and voltage sensor were connected. The iron electrode and the platinum electrode were immersed in a mixed acid solution. The two electrodes were connected with a voltage sensor to stimulate the galvanic cell formed during the corrosion process of iron. So here you can see the two drop count sensor. Then this one is the voltage sensor. Then number 5, which is the titration tube, and this is the platinum electrode. The greenish blue color is the platinum electrode, and this one is the iron electrode, the grey colored one. Then coming to step 3. Step 3, as we discussed, that it was a repetition of step 1 and 2. So steps 1 and 2 were repeated under the same conditions and operation to test the accuracy of the instrument. The consistency between the results of the two measurements could certify the accuracy of the sensors and prove the pH sensor and the drop count sensor to be well synchronized. Then coming to step 4, the voltage change. Measuring the voltage change. For measuring the voltage under hypoxic conditions, the steps are basically the same as step 2, except for the following additional steps to construct the hypoxic condition. Flow sufficient helium into the mixed acid and mixed alkali solution in advance, and start the measurement only after the voltage is stabilized. In the subsequent process, helium is continuously flowing into the solution. The purpose of these additional steps is to use helium to exclude dissolved oxygen in the solution.
Yeah, usually this is what I did personally. I did extensively oxygen reduction electrochemical studies for fuel cell applications. Whenever we wanted to measure oxygen reduction, yeah, we take such precautions. Okay, please go ahead.
So the new things that were in this were the helium pipe, which was added directly into the beaker to like bubble. So oxygen would be replaced by helium. So no oxygen would interfere with the experiment. Then step 5, measuring dissolved oxygen concentration change. A mixed alkali solution was titrated from the plastic titration tube into the beaker containing 50 gram of mixed acid solution. In the whole process of titration, the drop number sensor was used to measure the volume of the mixed alkali solution, and the dissolved oxygen sensor was used to measure the dissolved oxygen concentration of the solution in the beaker. The images are the same as the second step was, but only there is the helium gas is not there. Oxygen sensor is added. The number 4 dissolved oxygen sensor here, this black one. Then coming to step 6, measuring dissolved oxygen concentration change. This is for hypoxic condition. Step 6 is for hypoxic condition. For measuring the dissolved oxygen concentration under hypoxic condition, the steps are basically the same as step 5, except for the following additional steps to construct the hypoxic condition. Basically, we will be adding helium gas to create the hypoxic condition. Otherwise, it is the same as step 5. So, hazards in this experiment, which we need to be careful of. The 0.05 molar hydrochloric acid and 0.1 molar sodium hydroxide solutions are volatile and corrosive. Thus, goggles and gloves need to be worn during the experimental operation. Acid and alkali waste liquids should be recycled in designated containers and cannot be poured into the environment. Helium cylinders are compressed containers, basically 2 megapascal of pressure is maintained. Thus, they should be used strictly following the manufacturer's instructions.
Yeah, this is a very useful instruction, students. You should not, neglect the laboratory safety practices. It so happened that the Nobel laureate of this year, who are the Nobel laureates for chemistry in this year? Yes, Caroline Bertuzzi, Sharpless. What's the full name of Sharpless? Curl, Berry, Sharpless. And the third scientist, Melda. These are the three scientists that are awarded Nobel Prize for bioorthogonal chemistry and click chemistry. Caroline is like our friend Isha. Caroline has started bioorthogonal chemistry 20 years ago, for her remarkable contributions to bioorthogonal chemistry, which has implications of doing chemistry in human cells, without affecting without causing harm to the cells. Okay, for her achievement, Caroline, can you see the full name? Yes. Caroline Bertuzzi and Carl Berry Sharpless. Carl Berry Sharpless, what he did? Carl Berry Sharpless, in one of his experiments while he was an assistant professor in Stanford University, he was recording NMR without wearing safety glasses. Suddenly what has happened while he was seeing the NMR glass, it has exploded and the glass pieces have gone into his eye and he became blind. He is blind in one eye, Nobel laureate. That's what Parasar has told. When you do handle acids and bases in labs, you have to wear safety glasses. Agree? You have to use gloves. Chemistry, is beautiful. But as youngsters, you are expected to do chemistry under safe conditions. Okay? You have to handle acids and bases in glow box. Not glow box. In fume hood. Glow box is different. It has a different purpose. To do experiments with materials that are sensitive to moisture, we use glow box. Glow box is different, and fume hood is different. You are supposed to handle such chemicals, that are volatile, such chemicals that are, having toxic effect in fume hood. In laboratories, you will have fume hoods. Glow box is a different thing and it has a different purpose. Okay. Then you are supposed to wear safety glasses, you are supposed to wear apron. This is education for you to learn, okay? Professor, being an assistant professor, he did not wear the spectacles and he has to pay dearly, Losing an eye, is it a small thing? Yeah, you should learn from the experiences of great scientists like, Carl Berry Sharpless. Thank you, Yash. Please, go ahead. Sorry, not Yash. Parasar.
So the implementation, as we know, this experiment was to increase students' critical thinking ability. So how they implemented the whole thing. The complete demonstration experiment includes 6 titrations, each taking about 15 minutes. Although the complete demonstration experiment can be conveniently implemented on site, the titration process also actually similar and relatively time consuming, which may cause students to lose patience. In order to save time and improve efficiency, we only demonstrated the first 2 titration processes, that is step 1 and step 2 on site. For the remaining 4 titrations, only the built experimental device was displayed on the site as a video demonstration, and the measured data prepared in advance was shown instead of the on-site experiment. During the demonstration, students were divided into groups of 4 people and were asked to critically consider whether the evidence and reasoning of the experiment were rigorous in group discussions. 3 to 5 minutes each time. The initial scheme only included steps 1 and 2. First, the teacher demonstrated these 2 steps on site and obtained the curve of pH and voltage against volume. It was found that the voltage of the ion pattern of primary.
Excuse me, Parasar, can you please draw for us a plot of pH versus volume in the simple acid-base titration? Okay, HCl versus NaOH. Can you draw on the board? simple pH metry, you know. Yeah, you see, like this. pH, volume. Okay, at particular volume there is a steep rise in the pH at the point of neutralization. Yeah, here we see something similar, you know, potential or voltage versus volume of the titrant. Yeah, please go ahead,
It
Parasar.
was found that the voltage of the iron platinum primary cell remained around 0.75 volt under weakly acidic environment, pH 4 to 6. The oxygen absorption corrosion with a higher standard electromotive force of 1.669 volt must occur. Thus, the conclusion that oxygen absorption corrosion will occur under weakly acidic environment could be drawn.
Yeah, please. What is the conclusion? Iron corrosion not only takes place by hydrogen evolution but also by oxygen absorption under acidic conditions. That is the conclusion. Agreed? Yeah. Yeah, please.
So, results and discussion. As a result of the implementation, students found out defects 1 to 3 one by one. Table summarizes the table is below. The table summarizes the 4 values of the experimental scheme from the initial one to the final scheme. Each version except the final one had defects that need the students to use critical thinking, through which they found these defects and improved them with the teachers by supplementing more evidence and perfecting the reasoning process. The demonstration was designed to be modular and the step sequence to be flexibly adjusted. Teachers should reasonably switch the sequence of the steps according to the results of students' group discussion. Each time, improvement supplemented new evidence and made the evidence-based reasoning more rigorous. This demonstration may change the wrong tendency of students to focus on experimental conclusions rather than the process in the past and persuade them to pay more attention to evidence-based reasoning in future studies.
Yeah, evidence-based reasoning in future studies. Yeah.
So this is a table that they created after the experiment was
Conducted. Yeah.
So version of scheme, the initial scheme, like they divided into four schemes. How they made changes in the steps to make the questioning more like critical thinking type. So version of the scheme, the initial scheme, steps 1 and 2, new evidence. The actual voltage measured under normal conditions in the open system and defects. There was one defect. The evidence is not reliable since the accuracy of synchronization of sensors were not certified. In the first improved version, where steps 1 to 3, where after the steps 1 and 2, the step 3 was added. Add new evidence. The results of 2 repeated experiments matched well. Defects 1 was solved while defect 2 still remained. In the second improved version, steps 1 to 4 added with step 4 after the step 3. Add new evidence. The actual voltage measured under hypoxic conditions improved reasoning deduction. The actual voltage under normal conditions were higher than the under hypoxic conditions. The defects 1 and 2 were solved, but new defect 3 emerged. Are hypoxic conditions with stable oxygen concentration really formed by the flowing of helium? That was the question. The third improved version, steps 1 to 6, with addition of steps 5 and 6 again, add new evidence. The oxygen concentration after helium flowing was measured to be stably remaining at around 1 by 5 of the under normal conditions. Defect 3 was solved and no more defects could be proposed by the students and the teacher. So that was the overall summary of the experiment, and thank you.
Yeah. Let us give a big hand to Parasar for the very eloquent lecture. on the problem of corrosion in the specific example of iron corrosion happening under acidic conditions in two modes, one by hydrogen gas evolution and other by oxygen absorption. Thank you, Parasar, for the clear and eloquent lecture.